square function, right? It's a quadratic. This is our y equals x squared. Remember him from last semester? 3 months worth of that, right? That was like your whole life for 3 months was this function, okay? Okay, so let's draw its inverse. So how do I make the graph of any inverse? What do I do? What was the whole deal with last week?
You pick like the 3 points.
Yeah, I pick some points and I do what with them?
You switch them.
Switch x and y, okay? Now you can either, draw the points out here, right? Like I could take these points and switch them in my head, or since we know the equation, couldn't I just, since I started using my calculator, why not just keep doing it? X squared, look at my table and just swap my table around, right? So like 0, 0 is still 0, 0. But I can switch these around. Like what if I took like 2, 4 and I switch those around? What do I get? 4, 2, right? So 1, 2, 3, 4, 1, 2. And I can do the same thing with my negatives, right? I have negative 2, 4. Can I swap that around and get 4, negative 2? That's good enough. You don't need to do every point on the table, right? Just enough so you see what's going on. So here's our inverse. Okay. All right, what I just drew in red, our inverse, is that a function? What do you think? Is that a function?
No.
Okay, let's make sure we're doing what I'm doing. What I write, you write. Right, Angel? You got something to write with? Okay, let's pick it up. Let's do this together, okay? Yeah, this is not an inverse. Okay, or I'm sorry, this inverse is not a function. Okay, so that's important to remember. All right, our original domain. So original. So I'm looking at the one that's on the paper, right? That was printed on the paper. What's its domain? Y'all should know this from last semester. What's the domain of this?
No, miss.
It was the same answer every time that question was asked. It was the same answer every time. All real numbers, because the first semester you deal with functions whose domain is all real numbers. So all real numbers, or you can say negative infinity, infinity, right? Because if I extend this, my graph is going left and right forever, right? Okay, our original is range, but the graph does not go up and down forever, right?
No.
It has a bottom, and what's the bottom value?
Negative
0. 0, and it goes up to what? Infinity, yeah. Or, well, yeah, all real numbers onward, right? But the bottom is 0. So we would say either 0 to infinity that way, or we would say y is greater than or equal to 0. And that was our range of domain and range of our original. Okay, now let's look at the inverse. The one that I drew in red, okay? What's the domain of this inverse? Can I go left and right forever? No. Yeah, what's my, what would my domain be for this red one?
0,
0
0.
to what? Positive infinity, right? Or I would say x is greater than or equal to 0. There's 2 ways I can write that. And what about the range of our inverse? Will this go down forever? Will it go up forever? So what do I call that? When it goes into negative and positive infinity, what's that called? So that means any number in the whole world. What do we say that is? All real numbers. Okay, now look at the domain and range of our original and inverse. What do you notice? Do you notice this? The domain and range just switched. Why do you think that is? Because what did we switch to make the inverse? We switched x and y. Well, if we switch x and y, aren't we switching domain and range? Yeah. Okay. All right, now here's the big thing here. This red, not a function, right? Fails vertical line test right here. But I want to make this so that my inverse is a function. So I can do all the function things with it. Okay? So how would we need to restrict our x values so that we have a one-to-one function? Meaning, how would I need to restrict my original so that when I make an inverse, it's a function? What do you think? Ideas. You can't be wrong. Because if I take all of my x, y points on the black graph and I switch them, I get something that's not a function. Well, how can I, when I say restrict x values, how can I chop off some of this original graph? I'm just going to chop it off. It's gone. So that my original is a function. What part of the graph could I chop off so my inverse is a function? Do you see what part of this makes my inverse not a function? Look at these points right here. What repeats?
4.
Yeah, the x value of 4. Well, in the original, where is that? Those are y's, right? What if I only had one of those? Would I have an inverse that's a function? Yeah, because if I have both of them, look, this is not a function. But what if I only had half of the parabola? What part of my inverse would I have?
That.
Just the top part, right? Okay, now, is that red part, is that a function? Yes. So how could I describe what values of x did I keep in my original? I kept all the x's, because now this is all real numbers, right? But if I cover this up, what x values do I have now? Just positive ones, right? So I could keep only the positive values of x. Well, couldn't I do the reverse? What if I kept only the negatives? Then I would have only the bottom part of my square root function, right? Or my inverse, I mean, sorry. Does that make sense? So in order for this to be a function, how could I restrict the x values of the original so we have a one-to-one function, meaning our inverse is also a function? We could consider only the x values greater than or equal to 0 or less than or equal to 0, which means I only want half the parabola. Because if I have the whole thing, I have something that is not a function. And we don't need our phones right now, so go ahead and put them away. Thank you. Okay? So that's what we're going to do. We are going to only consider, but for our purposes, we're going to consider the values of y equals x squared that are just greater than or equal to 0. Okay? So I just want the values of x, so I'm going to say x is greater than or equal to 0. So I just want to look at these. Okay? That's called restricting a domain. Okay, so if I do that, if I only take the x values that are greater than or equal to 0, and I switch x and y, I get something that looks like this down here. And this is our square root function. Okay? So this is, and notice there's no plus or minus in front of that square root because I'm only taking the positive. If I take the positive side of the parabola, I have a positive square root. If I took the negative side of the parabola, I'd have a negative square root, okay? Okay, so what's the domain of this now? Because it isn't all real numbers. Where do our x values begin? When x is 0, right? So 0 to infinity, or in other words, x is greater than or equal to 0. And our range, where do our values of y begin? When y is greater than or equal to 0, right? Or 0 to infinity. Okay? Okay, so this is our square root function. So everything going forward, we're going to be dealing with this. Okay, in this box, we're going to talk a little bit more about domain restrictions, okay? So I'll just help you fill in the blanks here. So this first blank is going to be inverse relations. Inverse relations interchange the x values and y values. You already knew that, right? That's what inverses are. This results in the blank of inverse functions also interchanging the domain and range. Okay, so we're learning today that we're also switch our domain and range. Okay. The domain of the original function becomes the, what goes in this blank? Range. Yep, range of the inverse. And the range of the original becomes the domain of the inverse. Okay? And this last blank is the word domain restrictions. So domain restrictions may be used to ensure that the original function and its inverse are in fact inverses. Okay, so sometimes we need a domain restriction. So coming up, I'll show you what we mean by that in example 1. Okay? Is this big enough? Can we all see this all right? Okay. Example 1 says, find the inverse of f of x equals x squared plus 3, and this is a typo. This should say x is greater than or equal to 0. Okay. Okay. This part, x is greater than or equal to 0, that's a domain restriction. Okay? And it's put here so that we have an inverse that's also a function. So it says graph the function and its inverse on the same grid. So first thing I'm going to do is graph this. Okay? And honestly, you should be able to graph that without a calculator from last semester. I don't know how well we remember this from last semester. Nick, put away your phone. So you could also just type this in. Why don't we do that? Because I don't know how well you remember this. So if I want to make the graph of this, I can put it in my calculator, x squared plus 3. But you should realize that it's the quadratic parent function shifted up 3, right? It's just our quadratic shifted up 3. So I know I have a vertex at 0, 3. And I can go to my table to get some more points. So I have 1, 4. I have negative 1, 4, and I have 2, 7. Wait, 4, 5, 6. Yeah, right here. Okay. Oops. Whoa, 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 whoa. Wait, don't copy me. I don't know what I'm doing. I don't know what I'm doing. Hold up. What part of this am I supposed to graph? I'm only supposed to graph the part where x is greater than or equal to 0. So all of these I don't graph. I just graph when x is greater than or equal to 0. So I'm just graphing this part. And why am I doing that? Because that's what it says. It's not something I have to know, okay? That's just what it says. You don't have to know that, okay? I'm just absent-minded and just didn't read it, okay? All right, so this is our original. This is f. So what's the domain of this? Obviously, they told us, right? X is greater than or equal to 0. I'll just do 0 to infinity. Okay. What about our range? Where does y begin? Y begins at, what's that value of y right here? 3. Okay. Okay, if I want to graph the inverse, Nick, put away your phone. How can I easily do that? Well, I just switch x and y, right? 0, 3 becomes 3, 0. I could also use my table if I need. So 0, 3 becomes 3, 0, and then I can have 4, 1, right? Whoops. And 2, 7, if I switch that around, becomes 7, 2. Okay, and this is my inverse, right? Okay. Okay, Angel, you with us? Can you pick up your pencil? This is how we learn, okay? If I could walk around, if I could both teach and tap each of one of you and tell you to pick up your pencil, I would, but I can't do both of those things at the same time, so I need you to take care of your end, okay? Idea is, what is the domain of our inverse going to be? How do we easily find out? Domain of the inverse is the same as the range of the original. So what's the range of the original? 3 to infinity. And look, how do I know that? Look where this begins on the x-axis. It begins when x is 3. Nick, pick up your pencil. Okay? Range of our inverse. Domain of our original. What was the domain of our original? 0 to infinity. And that makes sense because look at the y-axis. Look at y begins at 0, goes to infinity. Do we all understand where we're getting this information on the right-hand side? Okay. All right. Now, there's one more piece to this. Figuring out the equation of the inverse. Okay? How do we do that? Look at these steps. Do they look familiar to you? They're the exact same steps as last week. It's the same stuff as last week. We're just using a different kind of function. Okay? I'm going to use black here because it's easier to see. All right, so step 1. If I'm going to find the equation of this inverse, rewrite as y equals. So let's write that. Y equals x squared plus 3. Okay? Some of you can safely skip this step. That's fine. And you can hop right to this next step, which is switch x and y. Right? So let's do that. Let's switch x and y. So x equals y squared plus 3. Everyone good? Feel like last week? It should. All right. Now we have to get y by itself. What do? Minus 3. So down here I'm going to put x minus 3 equals y squared. All right. Now I have to think, how do I undo squared? I square root. And whenever you take a square root, you are taking the positive and negative square root, right? So I have plus or minus square root of x minus 3 equals y. Okay? All right, but here's where you have to think. It's not going to be both plus and minus. Because if I had both plus and minus, I would have something that's not a function. So you got to decide, am I going to choose the plus or the minus? And you know where you look for that? Right here. X greater than 0. Does that mean positives or negatives? Positives. So I just take the positive square root. So in function notation, I put f inverse x equals positive square root of x minus 3. In fact, I don't even need to write positive square root because if I don't write anything, by default that means positive square root. Okay? And you know what? You could check, right? We could verify. How do I know if I'm right? I can put it in a calculator and see. Square root of x minus 3. And if I go to my graph, it should look like what I graphed. And I should see my x's and y's in there correctly. Okay? All right, now what questions can I answer about this first one? Okay, wipe your face off, shake it out, stand up, stretch for a couple seconds, get ready for the next one, okay? Because I see some of us are kind of zoning out. Got to come back. This is the way we learn. We got to come back. So do what you got to do. Stand up, stretch. You got 10 seconds. Do what you got to do. Deep breath, whatever you got to do. Okay? All right. Let's dive in. Example 2. Okay? We're going to find the inverse of this. All right. So now I have an original that is a square root. We're going to graph the function and its inverse on the same grid. Okay. You don't know how to graph this by hand yet. I'm going to teach you how to do that tomorrow, a very easy way, okay? But you don't know that yet. So if I'm asking you to make a graph of something that you don't know how to do without a calculator, you just use a calculator. All right, so let's pull out our calculator. Let's type this in here. So that's square root of x, and then make sure I'm out of my square root, and then I do plus 4. Okay? And then let's plot some points. So I don't have any negatives, so I'm starting with 0, 4, 1, 5, and these points are gross, so I'm not going to pick any gross points. How about 4, 6? And do I have another one that's good? Let's look. 9, 7. Okay, that's good. So that's our original. Okay? We all good? All I did was type it in and plot points. Okay, let's figure out our domain. What are our values of x here? Anyone? Where does x begin? Where does x begin? 0 to positive infinity, right? Okay. All right, our range of our original. So now I look bottom to top. Where's the bottom of this? What's this value of y right here? 4, right? So this would be 4 to infinity. Okay? All right, now I'm going to graph its inverse. So I'm going to switch colors for that. I'm going to do the inverse. Okay? And we know the way we do the inverse is we just switch the x's and y's. So let me go back up here, and I'm going to switch the x's and y's. 0, 4 is now 4, 0. And then I have 5, 1. And 6, 4. And I believe it was 9, 7, right? Yeah. So 7, 9. And there's my inverse. Okay? Everyone good with where we got that? Just switch x and y. All right, Nick, what's our domain of our inverse going to be? Domain of the inverse is same as the range of the original. So what's our domain of our inverse? 4 infinity, right? By the way, even if you forgot that, just look at the graph, right? It's like x begins at 4, goes to infinity. Range of inverse, that's the domain of our original, right? 0 to infinity. We all good with this? Okay, now let's make the equation. So we go over here. How do we do the equation? Same steps. So I'm going to rewrite as y equals f of x. So this is going to be y equals square root of x plus 4. Okay? Just changing the f of x to a y. Now let's switch x and y. So this will be x equals square root of y plus 4. Y'all with us? We good? Okay, now I want y by itself, and you have to start peeling away from the outside in. So first I have to get rid of this plus 4. How do I do it? Minus 4. Good. So I have x minus 4 equals the square root of y. Now I need to undo a square root. What undoes a square root? A squared, right? To the second power. Okay. So what I'm doing here is I would square both sides. That'll undo my square root. I take everything that's on the other side, I bundle it together and square it. Okay? That's how I undo my square root. I take everything and I bundle it and square it. So now I have f inverse x equals parentheses x minus 4 squared. Okay? However, if I were to type this in the calculator to check, right, if I have parentheses x minus 4 squared and I graph it, the calculator gives me the whole parabola, but I only have, when I made my graph, half of it. So that tells me I have a domain restriction. So this is not the answer. This is the whole parabola, but I don't have the whole parabola, right? I only have the right side. So I have to also give its domain. So it's just this for a domain of 4 to infinity. So I'll just say x is greater than or equal to 4. Because just leaving it like this isn't good enough, because that's telling me I have the whole parabola, and I don't. I only have half of it. Does that make sense? What questions can I answer about that? Please ask. I want to make sure you understand. I want to do everything I can do. We good? Okay, let's practice just this method, okay? We're going to leave this stuff over here, the graphing, for a second, and just focus on how we do this part. Okay? So let's practice that a few times. So here's a new example. Okay? This right here is a domain restriction. Remember, it doesn't necessarily matter for this process, okay? So we begin here. Are we all okay if I skip this step, rewriting as y equals? Okay, can I hop right to switching x and y? Most of you did that on your quiz anyway, so I think we're at a point where we can do that. So switching x and y, we get x equals y plus 5 squared. Okay. All right, you want to get to y, right? So what do you have to undo first in this one? Yeah, I can't get to the 5 yet because this whole thing is being squared. So before I can get to the 5, I have to undo the squared by doing what? What's the undo of what undoes a square? Square root. And remember, when you take a square root, you do positive and negative square root of x. And then you have to ask yourself, well, let's just keep going. And then what do I do to get y by itself? Subtract the 5, right? So I have plus or minus square root x minus 5 equals y. Okay, now I'm not going to have both positive and negative. I'm only going to have one of them. Okay, so you got to ask yourself, am I going to have... Oh, and by the way, make sure that that minus 5 is not under your square root, because you already square rooted, and then we're subtracting 5. Okay? We square rooted, and then we took away 5. I can't, like, sneak that 5 under the square root. That doesn't make sense. Okay? All right, now, what do you think? Are we going to have our positive square roots or our negative square roots? Look back over here. X is greater than 5. Is that a positive or a negative direction? Positive. So I just want the positive. So my equation will be f inverse x, got to write it in f inverse notation, is just going to be a positive square root of x with a minus 5. Okay? So you don't need a domain restriction on your square root. You just need to make sure you pick the right plus or minus. You need a domain restriction on your quadratic. Okay? What questions can I answer about that one? Is there any part of that you're not sure where I got anything from? Okay, let's try B. We're going to flip-flop it. Now my original is a square root function. Okay? So let's do the same thing. Switch x and y. So this becomes x equals negative square root y minus 2. Okay? I need to get y by itself. I can't do anything with that 2 because it's trapped under the square root. And I can't undo the square root yet because there's a negative in front of it. So how do I get rid of that negative? I divide it out. X divided by negative 1 is just negative x. This will be negative x equals square root y minus 2. Okay. What do I do next? Ideas? Square, right? If I square this, I knock out my square root. So I'm going to square this side. Okay, so I have negative x squared equals y minus 2. Then what? Getting y by itself, what do we do now? Plus 2. And the plus 2 happened after I squared, so now I have negative x squared plus 2 equals y. Okay, so inverse. By the way, if I'm squaring negative x, it's the same as x squared, but I'll just leave it like this for consistency. Okay. Now, if I graph this, right? That's the whole parabola. Do I want the whole parabola? No. So look at my square root. I took a negative square root, right? Y'all see that? In the original, it was a negative square root. So if I had the negative square root, I just want the negative side of this. So my domain restriction will be for x is less than or equal to 0. Why less than? Because it was a negative square root. If it were a positive square root, I would pick the positives. Okay? Okay, take a minute and test yourself. You guys try C. Okay? Follow the exact same steps. Try this and see how you do. We'll check it in just a minute. So test yourself. Okay. Did we all switch x and y? We all do that? Now we get y by itself, so you minus 6. And now I square root. So I have the positive and negative square root of x minus 6 equals y. And the whole thing is under the square root because I square root everything that's on this side. So it's the square root of all of x minus 6. Okay? All right. Do I want the positive or the negative square root? Look back here. Do I want positive or negative? Greater than 0 is positive. Yep. So my answer is going to be f inverse of x equals the positive square root of x minus 6. That's it. Okay? All right, we're about to leave this and just verify real quick. So do we have any lasting questions on this process? Okay, let's do one of these, and then we'll finish with the other two when we come in the class tomorrow. All right, so let's say I have two functions, and I want to check to see if they're inverses. So I'm not going to do this, because this is where I just have one, and I try to find the other. Now I have two. I want to check to see if they're inverses. This is where I do function composition. So I want to put g inside of f and see if we have an inverse. Okay? So I look at my outer function, which is f. That's my shell. F is my shell. So I'm going to write function f, but when I see x, I do like big parentheses. So this will be parentheses squared minus 10. Right? All right, and then inside the parentheses goes g. So inside the parentheses goes square root x plus 10. Y'all see that? This is going as the input here. Okay? Okay, now we simplify, and don't assume you know what's going on. I have a big long square root squared. What happens with that squared and that square root? They cancel. So I just have x plus 10. And then I have minus 10 outside, right? And what happens to plus 10 minus 10? Cancels out. I just have x. Okay, when that happens, do you have to do the other one? Do you have to do g of f of x? Yes, you do. So now I'm going to go the other way. G is now my shell. So I'm going to write function g. And x just becomes a big parentheses. Okay? And in the parentheses goes function f, which is x squared minus 10. Right? I'm writing function g in the place of f is big parentheses. Okay, now look here. See how this is all under the square root? Can't I simplify this minus 10 plus 10? So those will cancel out. I just have square root of x squared. And what's square root of x squared? It's just x.